In the last video we saw how strings are declared. Remember that C does not have a built-in string type. There is no string class. There is no variable of type string. What we use is an array of characters. And so if you had a string, if you wanted to define a string, this is what you do. You say char space and then whatever name you want, open close square brackets, roughly the length. And when I say roughly the length, the reason for that is that you need one more space than the number of characters in your string to hold the NUL-termination character. So remember, this is the C convention that's used in almost every library function, which is that strings are null terminated. That is, the end of the string is indicated by a \0. So if you have a string, if you have a string named S, remember it's just a character array. You can assign it a value using double quotes, just like a string in Java. So this part is just like Java, although this part is quite different. Here in Java you would say string S is equal to open or double quote and then whatever string you want. But in C, you have to use an array of characters. The other thing to remember is that there is no length in arrays, in C arrays, and therefore you have to keep track. You, the programmer, has to keep track of how much space you need. So if you need space for this string, this is 5, 6, 7, 8, 9. There's only 9 characters in your string, but you need one more to hold the NUL-termination character. This is what tells all the library functions used in C where the string stops. So you can have more than 10 characters. You can have 11, you can have 100 if you want, but you'll only use, if you have a NUL-termination character at position 9, you're only using the first 9 locations of this array. Okay, so in C there is no absolute start or end point for strings. So you could have a character or string S and within 10 spaces in the array using this as the contents of the string, and you can start at any point between 0 and 8. Actually, you can start at 9 too. So any point between 0 and 9, you can start another string. So for example, S sub 2 is a character and is the starting point for a valid C string, and this in this case would be LLO space 248. So if you start from position 2 of this string S, S starts way back here at H, but S sub 2 is L, and this can be treated as a starting point for a different string. So at any point in this string, including the 9th location, which tells you that there's a null termination, that's an empty string. So if the very first character of a string is a null termination character, what you have is an empty string. Okay, so having said that, what you will see normally in most C programs is that strings will be usually declared as pointers to character. And it's essentially the same thing. It's just that you're not saying how many characters you're saving for this S. So if you were to say char star S, if you ignore the rest of it, it looks like you're saying S is a pointer to character. But here's the thing, whenever you see char star S or char star anything, you want to think, okay, this is a pointer, but probably a string. And it turns out it's both. So in this case, S is both a pointer and a string. So how can it be that? Well, that's how C works. So when you say char star S, ignore the rest. You're saying S is a pointer to character. You assign it this value in double quotes, hello to 48, and what you're saying there is that now S points to an array which has 1, 2, 3, 4, 5, 6, 7, 8, 9 locations plus 1 for the null termination character that's added automatically. So no longer do you have to say that S has 10 locations. You can just say char star S equals whatever you want. And most C programmers find this a lot more handy to write because they don't have to figure out how long the string is and put in the right number of characters and right number of spaces in open close square brackets. Okay, so C does allow you to access substrings using pointer arithmetic. This can be kind of confusing, so we talked about this just in the 2 slides ago. If you were to printf a string, you use in double quotes, you use %s to indicate that you're printing out a string. And so you can print out starting from S or any other location, any other valid location in that array. So I just want to remind you that even though we said S is of type char star or pointer to character, really when you set up a string, all you're really doing is setting up an array. Okay, so just like before, you can say S. You can say S plus 2, that is starting at the L. This is a string, so if you were to print out using the string format character %s, S plus 2, this will print out these characters and it'll print out everything until it hits a null termination character. Okay, so this is extremely handy, but at the same time it's very unsafe, because what happens if you were to somehow inadvertently remove this null termination character? Well, then a printf like this will go beyond the bounds of the array, and there's nothing there to stop it from doing that, because all it's looking for is the null termination characters. And if you remove it, it'll keep going until it hits a null termination character. And by that time, it might be so far beyond the bounds of the array that it might have accessed some part of memory that it should not access, and as a result, it'll probably get a segmentation fault. Okay. Let's take a more detailed look at the printf function, and this is basic output to standard out. So printf is what we use in C programs to print something out to the terminal. Here's a simple example. We say that we have a car, and we use the more straightforward declaration. We say, instead of saying char star, we say str is an array of 14 characters, and we initialize it with the value hello world, which needs 1, 2, 3, 4, 5, 6, 7 for the space, 8, 9, 10, 11, 12, 13, and then of course we need one more space for the null termination character. That's why this says 14. Okay, so this would have been exactly the same as putting this thing in double quotes, including the double quotes, put that right into printf, and it would have done the same thing. So the way printf works, the first argument of printf has to be a string, and it's usually used for formatting output. And what does formatting mean? It means it has those formatting characters, like %d is a format for decimal digits. Okay, so you've seen that in previous programs, and what you can do, and we haven't done so far, is you can declare a string like that with formatting characters as a separate string, and then supply that as an argument to printf. Typically you don't see that a whole lot, but that's perfectly fine. You can do that. You can say that you can declare the string and then supply that as an argument to the printf function. And so previously what we had used was we specify this literal string constant right in the printf. And then we use the %d that refers to decimal number. And so the num, whatever it is, will be printed out in decimal form. So some of the other options are even binary or hexadecimal or octal. In our case, most people find it easier to read decimal, and so therefore that's why we usually see a lot of %ds. In addition to printf, there are some low-level I/O functions, and these come with #include stdio.h. So stdio.h is where these functions are defined: getchar and putchar. Getchar gets a single character from standard in, and putchar, as you can imagine, puts out a single character to standard out. Now, it turns out that the argument to putchar is int, but what it really wants to do is take the least significant byte of that int and put that out. So although you are allowed to put in an int, you don't have the complete range of an int. All it does is really put out a single character. So, and putchar returns a character, getchar returns a character read, and putchar returns the character written as an unsigned char cast to an int. So it's a little bit complicated, but even though getchar only gets a single character, it actually returns an int, but only the least significant byte contains the information that getchar actually gets. Similarly, putchar, whatever it puts out, whatever it writes out to standard out, it returns an int form just for compatibility with other functions. But we know that it's only just putting out a single character, and so therefore only the last or the least significant byte of this int holds valid data. Okay, so here is a simple example of a program that uses getchar to get things from standard in, and putchar to put the exact same character back out to the standard out. So all this does is something like an echo. This will get a character, so if you type in a character, it'll go into C, and then it'll print it out back out to the screen. So if you were to run this, if you were to run a program like this, all you would see is whatever you type in, you hit enter, and you get the same line back. So this is a simple example of using getchar and putchar. Next up, we'll look at some low-level file I/O that is using the getC function. It's a lot like the getchar function, only this works with files.